All right, I need to look at my domain first for 2x over 1 plus x squared, and this is y equals. So 1 plus x squared cannot equal 0 because you don't want to divide by 0. So x cannot equal plus or minus I. Well, we're on the real number system, and so that is hard to see. There, that's a little bit better. We're on the real number system, and so we don't care about imaginary numbers. Okay? I hope that's okay for you to see. Sure. Okay. So anyway, what we have is first derivative is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay? So I'm going to clean this up a little bit. This gives me y prime is over 1 plus x squared squared. So I have a 2 plus a 2x squared minus a 4x squared gives me a 2 minus 2x squared over 1 plus x squared squared. Okay? So looking at this, what we need to do is take a second derivative. First derivative is increasing, decreasing, maxes, and mins. Second derivative is concave up, concave down, and points of inflection, and we're trying to find concavity. So that's what we're looking at as a second derivative. So my second derivative is the bottom times the derivative of the top, which is a negative 4x, minus the top times the derivative of the bottom all over the bottom squared. Okay, so I've got this big old chunk minus this big old chunk, and I notice that both of the big old chunks have a 1 plus x squared in them. So I'm going to factor out a 1 plus x squared. So 1 plus x squared is going to leave me with a 1 plus x squared times a negative 4x minus 2 times negative 2x squared times 4x all over 1 plus x squared to the fourth. Sorry, that should have been a fourth right here. And this should be a fourth because it's over the bottom squared. Alright, so what do we have? I've got this chunk, which is a 1 plus x squared equal to 0. Well, we've already done that up here, and we know that that's impossible to do. Pardon my dog barking in the background. Hush. And then we have the other one, which I'm going to distribute this negative 4x. So I have a negative 4x minus 4x to the third minus 8x minus 8x to the third all over 1 plus x squared to the fourth. Okay, and I'm going to erase this because the only way to make a fraction equal 0 is for its numerator to equal 0. That's why I kind of dropped it off right over here. Hang on just a second. My dog is having a hernia. Do you need to go outside? Hang on one second. Alright. So what we have is, I'm going to distribute this negative 8. Remember, I dropped the 1 plus x squared to the fourth power, because the only way to make a fraction equal 0 is for its numerator to equal 0. So I took this factor and set it by itself. I simplified this factor, which I'm still working on. And this one is a no, because just like we did up here with the domain, it's impossible for this to equal 0 unless you go into imaginary numbers, which we're not going to do. So now what do I have? I have a negative 4x minus 4x to the third minus 8x plus 8x to the third equals 0. So that gives me 8x to the third minus 4x to the third is 4x to the third. And then negative 4 and negative 8 is negative 12x equals 0. So what do I have now? I have a 4x being factored out, and that's going to leave me with x squared minus 3 equals 0. So 4x can equal 0, which would be x equals 0. And then x squared minus 3 can equal 0. So add 3 to both sides. And I get x squared is 3. Can you see what I'm writing? X squared is 3. Take a square root of both sides, and I get x equals plus or minus root 3. So you have 3 numbers that you're going to use to set up your intervals. One is a negative root 3, one is a 0, and one is a positive root 3. And you're going to put that into your second derivative, which is this one right here. And the criteria is the same as if it were increasing, decreasing. You're just checking for concavity instead. Alright, the next one that we're doing is number 18. I think I had the last one labeled as 15. I did. It's not. It's 17. Anyway, here we go. I have e to the 6 over x, and I changed that to e to the 6x to the negative 1. And so that it would be easier to take a derivative. So my first derivative, which has to do with increasing, decreasing maxes and mins, is going to be write what's sitting there times the derivative of your exponent. Okay? So now I've got variables times variables, and so my second derivative is going to be product rule. So I have the first times the derivative of the second, which is 12x to the negative 3, plus the second times the derivative of the first, which is e to the 6 to the negative 1, and then times the derivative of your exponent is negative 6x to the negative 2. And all of that is equal to 0. So I'm going to clean this up and rewrite so that my e's are last. I want my coefficients first and then my x's. So when I rewrite, I have 12x to the negative 3. E to the 6 to the negative, e to the 6x to the negative 1. And then I've got minus 36x to the negative 4. E to the 6x to the negative 1. And that's equal to 0. So I did negative 6 times positive 6 is negative 36. X to the negative 2 and x to the negative 2 is x to the negative 4. So I'm going to factor out an e to the 6x minus 1, or to the minus 1. And that's going to leave me with 12x to the negative 3 minus 36x to the negative 4 equals 0. So for this chunk, I'm going to factor out an x to the negative 3. I don't know if I would do that yet. Let's rewrite this first. So I'm going to write this as 12x to the third, 12 over x to the third, minus 36 over x to the fourth equals 0. I'm going to add my x to the fourth over. This is impossible, by the way. So this is a no. So I've got 12 over x to the third equals 36 over x to the fourth. So cross multiply. Okay. And then what do we have? I can divide both sides by 12. So I've got x to the fourth equals 3x to the third. Now I'm going to subtract 3x to the third from both sides. So x to the fourth minus 3x to the third equals 0. Factor out an x to the third, and that leaves me with x minus 3 equals 0. So x equals 0, or x minus 3 equals 0. So add 3 to both sides, and x equals 3. So we've got 2 points. We've got 0 and 3. And then check that into your second derivative, which would be this. So use your test points and go in there to determine your concavity and your points of inflection. All right, we have a -8 natural log of 49 plus x squared. So -8 is going to come along for the ride. And the derivative of a natural log is the derivative of an argument. So that's a 2x over the argument itself, which is in descending order is x squared plus 49. So that's my first derivative. I'm going to clean that up just a tiny bit and make that into a -16x over x squared plus 49. Okay. So now what I have, this is my first derivative. My second derivative is going to be quotient rule. So I've got the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And it's important to notice that your domain is still all real numbers. Okay? Actually, that is a blatant lie. Hang on, let me think. Because we're starting off with a natural log. So we want the argument to be greater than 0. So yeah, our domain is all real numbers. Because x squared can't equal a negative number. So our domain is all real numbers. And now what are we going to do? The only way to make a fraction equal 0 is for its numerator to equal 0. So I'm going to distribute this -16. So I have a -16 x squared minus, what is 16 times 49? 784. And then I've got plus 16x times 2x is 32x squared equals 0. So I'm going to combine like terms and get 16x squared minus 784 equals 0. I'm going to add 784 to both sides. So I get 16x squared equals 784. Divide both sides by 16. So 784 divided by 16 is 49. And take a square root of both sides, and x equals plus or minus 7. Okay? So what does that mean? That means that you've got a -7 and a +7. And you're going to put your test points, which I've been letting you do instead of me do. Put your test points into your second derivative. If it comes out positive, it's concave up. If it comes out negative, it's concave down. And you should have points of inflection at -7 and positive 7. Okay, and that's good for this video.